Hi guys, here I am recording the vodcast to homework 4.4. Now, this is from the 2008 examination, and I'm doing this in purple today, so we'll see how that works. Actually, this is inspired by Nick Lautoa, Block 3, who encouraged me to do purple in class, and I really enjoyed it. So, we see a graph here, and doesn't tell us what reaction this has to do with, but it's okay. It involves NO and O2. So we want to determine the order for the following reactants and give details of your reasoning clearly, clearly explaining or showing how you arrived at your final answer. So basically this means show work. Okay, so for NO, we want to know where O2 is constant. And I'm actually going to do this one up here so we have work. So this should look very, very, very similar to the one we did in class today. I did this for a reason. That's going to be experiment 1 and 3. And in experiment 1 and 3, I'm going to look at NO, and then I'm going to look at the rate. Okay, so the NO in experiment 1 is 0.02, and in experiment 3, it's 0.06. I'm going to raise both of those to the question mark power. And I notice that I have 8.52 times 10 to the negative 2. That's going to be 0.0852. And I'm going to divide that by 6.67 times 10 to the negative 1, which is going to be 0.767. And what I'm going to get down here is I'm going to get 0.33 question mark equals, and I believe this ends up being about 0.11. And we know that question mark can either be 0, 1, or 2. If it were 0, this would be 1, so it's not 0. If it 1, that would be 0.33, so we know it's got to be 2. So the order for N is second order, and here's our work. Make sure they do see that. So let's do this for O2 next. That's going to be where NO is constant. That happens between 1 and 2. And we know that we are going to do O2 and we are going to look at the rate. O2 goes from 0.03 to 0.09. And the rate goes from 0.0852 to 0.256. So this is again going to be, I'm going to do this in my little calculator on my iPhone to make sure that I have it. I will stop talking that way because that sounds really stupid. Where are you, calculator? Calculator. 0.03 divided by 0.09, that was a toughie, is 0.33, and 0.0852 divided by 0.256 equals, oh, look at what we have here. So in this one, it's going to be first order. Nice. So this is going to be first order. Write the expression for the rate law. So I'm going to do this down here. Rate equals K NO squared O2 to the first. Nice. Determine the value of the rate constant for the reaction to clearly indicate the units. So I'm going to do value first. I'm going to do units second. So rate, I'm going to pick experiment 1 for the value. Equals K NO squared O2 to the first. Okay, so for experiment 1, the rate was 0.0852. Equals, we'll do this later, equals K, and NO is 0.02, and O2 is 0.03. 0.02 squared, 0.03 to the first. Double check to see that's okay. Yep, so I'm using this experiment here. Okay, so I'm at 0.0852 divided by 0.02 squared times 0.03. let's do that in our calculator here. So clear 0.02 times 0.02 equals that times 0.03 equals that. So this is 0.08552 divided by. So clear 0.0852 divided by 0.0. Okay, so this equals 7,100. And now let's get the units. So for the units, I do the same exact thing I did here, but I do it with the units instead. So the units on rate are molarity per second. And there's K. And the units on each of these are molarity. So remember that moles, liters, -1 equals molarity. It's a lot easier to do it that way. So I got molarity squared, molarity. You rearrange all these, you end up with K equals this. So K equals 1 over molarity second squared. So 1 over molarity second squared is the units. Have a great day, guys. Take care.